Hi everybody. I hope you can see me. Just a second. Thank you for waiting. Hi everybody. I hope you can see me. Can you confirm you can hear me without echo? I think it was echo.
Yeah,
Yeah.
you are audible.
Yeah, okay, awesome. So, hi everybody. Today we have Shardeum with us. I'm very, very excited to announce. I don't think so. They need any introduction. But we have Sandipan from Shardeum joining. He's a DevRel engineer at Shardeum, and I'm very, very excited to announce him. Yeah, I think we can have him over. Yeah, hi Sandipan. How are you?
Hey, hi, Pretty. Hi, everyone. Thanks for having me.
Yeah, I'm sorry for the little hiccup we had, but I think we can just get started with the workshop. If you all are watching this right now or later, to take this as an inspiration for Shardeum Bounty statement, you already know that we have a $55,000 of bounty at BRB, and Shardeum is one of our bounty partners. We will be learning all about the bounty statement for Shardeum, as well as about Shardium today. I'm very, very excited about it. Yeah, the stage is yours.
Awesome. Thanks a lot. Hey, everyone. Excited to share about the bounty and a little bit about why we decided it, and also give you a little bit background about Shardium for those who are not already aware of. With that, let's get started. I have a quick presentation, and then we will jump onto code too, but
Yeah,
it's a
I'll just share the
combination.
bounty statement in the chat as well, just in case everybody needs a quick access for it. Um, okay, sorry. Not
Sounds good.
awesome. So the stage is yours. I'll go backstage. If you have anything, do let us know. Yeah.
Sounds good. Okay, I'm sharing a screen. I think you will have to add it probably. Yeah. Cool. So yeah, let's get started. As I mentioned, like we will start with a bit of a presentation kind of way, and then we will at the end jump onto the code also. It's a very interesting bounty statement. We have put in a lot of thoughts, and it's once implemented, like will be like a very big game changer and will showcase Shardium's main features. And we are going to talk about a little bit about Shardium also, and the features and why, like you may need the context on why we put up such a bounty. And it's a very creative bounty, like, and I'm very excited to see all the solutions. But yeah, so let's directly jump. Like, I'm going to go through very fast on the sharding and the Shardium part, and then we will jump to the AMM part. Um, what is sharding? So basically, for those who are not already aware, like Shardium is an upcoming L1 blockchain. Like, why upcoming? Like, we are still in our testnet stage, and we are going to main it next year soon. And an upcoming L1 blockchain whose main key concept of scalability is through dynamic state sharding. And this sharding concept, I think for those of the developers who have worked with database are already aware of. It's basically breaking down into multiple smaller chunks so that you can handle data and make it more efficient. And in case of a context in a blockchain, the sharding is a concept of splitting the blockchain into smaller and more manageable shards. Shards are nothing but just a collection of nodes. And yeah, like in majority of the wise, like in other blockchains, you will see like sharding in some aspect or other. But in Shardium, like we have, like the team has implemented sharding in all three cases, in which like it's not only on compute, it's also on storage, the state. So it's an all-rounded sharded blockchain from like block zero. So that's the difference between like Shardium and some of the other implementation of sharding in other blockchains. And so quickly going to the state in a sharded blockchain, you may be aware, like in a general blockchain stage. For example, let's take the example of Ethereum. This one common state is the state of the entire blockchain, and if you make any changes, the state changes from A to B, and that's how like each blocks are produced and the transactions are happening, and the state of the blockchain is constantly changing. But what that requires is that in case of an Ethereum, all the node needs to hold the entire state of the blockchain. What we call full nodes need to hold the entire state of the blockchain, making the nodes much more bulkier. Like it will make it much more heavier to run with more hardware. And it's also like the entire network is only capable of processing as the weakest node in the network. So if a node that is why the reason we have blockchains like Ethereum is like it has not been able to scale up more than 28 24 TPS, because it's the entire network state is dependent on the weakest link in the weakest node in the entire network. So that's why, like, since each of the node hold the entire state, it's not very efficient. So in a state sharded blockchain, what happens is that each of the shard only holds a portion of the network state. So instead of having the entire chunk of the pie, it only holds a piece of it. So that's why it's much more efficient, and it's able to process the transactions much more faster and parallelly. That's the important part: parallel transaction. And so yeah, that gives us more scalable and decentralized. Why more scalable? Like, you can, each of these shard in itself now forms a blockchain and can do its own transaction, and it's much more decentralized because you are not limited by the number of nodes. Even like in a sharded blockchain, the more number of nodes, the better it is. We will get in the future why that happens also. But yeah, like the sharding, why and how we like initially I'd like talked about like the dynamic state sharding as one of the key concept and offerings of Shardeum. And in case of like, so there are multiple concepts of static state sharding, dynamic state sharding. And in Shardeum, like we have the dynamic state sharding, which is one of the like most advanced stage of sharding. That's why you are able to unlock the maximum capacity of the blockchain, in which like each of the node is responsible for a dynamic address range. So for example, if you take this shard, and shard is just nothing, a group of collection of nodes. If there are 100,000 nodes, 5 nodes can form a shard, or 10 nodes can form a shard. So it's just a collection of small part of the blockchain instead of the entire blockchain coming to consensus. And what happens in Shardium is like we have what we call like an address range. So for example, the entire network has an address range. So each of the shard is responsible for part of the address range instead of the entire address list. You can imagine it as an array, and like you can think of it as just a chunk of an array and not the entire array. So what happens is like each of those shard, instead of having in a state in a static state sharding, instead of this having the same thing like 1 2 3 3 4 5 6 7 8, instead of that, you are having dynamically, the shards are being formed dynamically. Why this is important and why this is helpful, we'll again like get to the next slide and we will get to know about it. But that gives also a layer of security, and also because if it was fixed, it was static state sharding, you would know that what data lives in what shard. But since it's dynamic, like it's completely random and the shards form dynamically based upon the transaction required. So that's why the dynamic state sharding is a much more better and like much more secure like method of dividing the blockchain, right? So in this case, let's see, each partition is covered by n nodes, where n is the consensus as group. So like you can see, like for example, in shard 1 we have 1 2 3. Now in shard 2 we have 4 5 6, two different address ranges. We have 7 8 9, and now you will see in shard 4 we have ABC, like an entirely different like concept. Instead of like having it in the same thing and having this entire thing in one list, we are like having it dynamically a lot into different shards. So yeah, again, like I'm going very fast on these topics, but the main concept of this workshop is about the problem statement and about the AMM. So I'm explaining these a little bit faster, but you can learn more about it in the Shardeum docs, and it's like you even in the Shardeum protocol, which Shardeum uses, you can learn more about it in its upcoming white papers also. And yeah, the two major features on why are we talking even about dynamic state sharding, and why are we talking about the bounty statement which we gave, and why is it important. The two major features why the bounty statement we gave is even possible is because of these two things. And these are the, you can say, as a barrier why you cannot implement this particular bounty in something like Ethereum. Atomic composability. As you can understand, we discussed a couple of slides before. The state is sharded, and each of the shard only holds each of the nodes only hold the portion of the entire network state. So the nodes in Shardium doesn't have the context or awareness of the entire state of the blockchain. So this is why it's important. Like if you have one shard forming here, one shard forming here, one shard forming here, you have a contract which is living in this shard, and you have another contract which is living in this shard. And this contract, like you have a solidity code which basically says that contract A calls contract B. If you don't have atomic composability, that won't be possible. And because because this doesn't even have the context of how to execute B, and it doesn't even have the state of how to execute B, function B, which is living in this shard. So this is one of the features which Shardium has built into it, is atomic composability, because whenever you are sharding a blockchain, it breaks. Atomic composability breaks. But that's one of the major features of Shardium. You retain the atomic composability, so you can just have your, even if your contract is in, contract A is in shard 1 and contract B is in shard 2, you can be ensured that when you call, just like no change in code required, when you call the contract B function in contract A, it will be executed, and the protocol handles that communication and whatever that needs to be done. So that's one of the major features why atomic composability requires, and why you will understand when I come to the problem statement why this is important when you're trying to build a parallelized EMM. And the second part, how Ethereum or like in general EVM blockchains function is they form blocks. And until you form block like 101, you cannot move, you cannot form block 102. You cannot directly jump from block 100 to block 102. You need to you need to form those blockwise. That is one of the major, like I would say, it's limiting the capability of why you cannot have a parallelized something like a parallelized EMM. But in case of Shardum, again, like Shardum does form block. I will explain also why it does. But protocol, at the protocol level, each transaction in Shardum is transaction based, like it's not block based. The consensus is done on each of the transaction. So even if you're sending A to B, for example, you're sending 2 USDC from A to B, that that transaction will come into the blockchain. We will read, what we call an address space on like what are the contract addresses or the wallet addresses involved. We will form a list, access list, which we call in Shardum. The access list will be formed, and it will be formed automatically by the protocol. You are still sending just a normal transaction. The access list will be formed, and based upon the access list, the shards will be formed, because who has the access. Once the access list is formed, the network will be like, which node has the required data to have this transaction occur, and then the network will figure out that these are the nodes. Those nodes will come together, form a shard, and then just for that transaction, in that one single shard, a transaction will be done. So for each transaction, you are having transaction level consensus, and this is why one of the major benefit you will get while using Shardeum is, and you can use that and implement something like an parallelized AMM. So these are the things which, why the context of how is it even possible to build a parallelized AMM, and like the tech behind Shardeum which is supporting it. So that's the whole context of like the Shardeum part, and the why something like a parallelized AMM is very, can be very, not only very useful, but also like why is it even possible. So yeah, now I think that's all on the Shardium part, and that's basically what you need. Again, like if you have any queries, or like we can discuss this about at the end of the session, but also sharding and the dynamic state sharding part. Now Shardium has also released its white paper recently, so you can learn and read more about it in depth all you want. And in future we are going to be launching courses too. So yeah, it's fine like if you don't get the entire concept, but like I hopefully like you can understand why something like a parallelized AMM is even possible in sharding, and what is the tech behind sharding which is supporting something like that. And let's come to the AMM part. So let's start with, yeah, let's start with how does even like current Web2 solutions handle trades. For example, if you are in the stock market, and if you have any of you have used or like bought shares of any company in the stock market, what you have in general is, I should have added a diagram here to visualize, but yeah, you can get an idea of what happens is like it's an order book kind of a thing. There's a buy column and there's a sell column. And what basically happens is a bunch of people are posting trades on the buy column, a bunch of people are posting trades on the sell column, and whenever the trades are matched, the trades are executed. And that's how like in Web2 context, trades happen. You can swap anything, like it can be like a real estate token, or something like a basic stock. So that's how it happens. But in case of Web3, like that's not the very efficient way of doing things. So in case of Web3, what we have is pool. So we were going to be talking about Uniswap a little bit down the lane, but for example, here we have, I think even if you have like used Uniswap once, you will get an idea on what I'm talking about. What Uniswap does, Uniswap is one of the biggest AMM out there, right? So you get to swap tokens from one token to another. What happens is that each of the pairs, like for example, in this case, we have each USDC pair. So each of the pairs are like they like you have in the Uniswap pool, each of the pairs listed. So each USDC, you will have SHM USDC, SHM USDT. So similarly, the pairs are present. What happens is that there are on one side liquidity providers, people who are providing the liquidity for making the trade happen, and then the other side there are the traders. So instead of having that order book kind of a thing, this is also a similar way, but instead of matching each of those orders, because you will need always a equivalent order to fill that particular order. Since in Web3 context, it's going to be much more difficult, or we even have fractionalized, like you can swap 5.66 ETH with a USDC, equivalent amount of USDC. So in that case, you can understand how many combination and how many orders can be even formed. So that's why what we have is called a unified liquidity platform, in which there is just a side which just provides liquidity. They give in their ETH, they give in their USDC, and then this pool is filled, and then the traders are just swapping between ETH to USDC, USDC to ETH, whatever that happens. So that's the basic overview of how most AMMs, I would say like all of AMMs, there can be some outliers. Like a basic AMM is, this is how a basic AMM works. And for those of you like who are thinking about what's an EMM, it's an automated market maker. So what happens is like you have like the market is being provided by the liquidity provider, and then you have the traders. And since the market making is happening automatically, it's an automated market maker. So that's the whole concept between Uniswap and AMMs and current scenario. So that's all you need to know about AMMs and how they work. It's a little bit more in depth, obviously, but this is an overview of how that works. And by the way, like each of these pools which we are talking about are smart contracts in itself. So we have a ETH USDC pool, we have a ETH USDC smart contract. Now coming to formulas. Now we'll need to talk a little bit about formulas. Like it's a little bit about maths when we are talking about AMM. I don't like maths, but when we are talking about AMM, like we need to talk a little bit about it. And this is the very simplified, very basic equation of how an AMM works. Obviously, like the entire Uniswap protocol isn't based upon just this equation, but this equation gives you an idea of how each of these pools are working. So you have x into y equals to k, a very standard equation which we all have like learned at certain point of time in our life. And what x represents is token A. For example, in this case, it's ETH. Y represents token B. It represents USDC. And K is a constant. What this basic formula is representing is whatever this multiplication factor is, this always needs to remain constant. So if you deduct some part of x, you need to like if x reduced by some part, y needs to increase by some part, and the k will remain constant. If x increase by some part, y needs to reduce by some part, and k will remain always constant. That is how like a pool is working. If you're swapping between ETH to USDC, like your ETH is like decreasing and your USDC is increasing. So that's how like you're swapping between one token to another. But the key important part is the K needs to remain constant. If there is 300 million worth of ETH and 200 million worth of ETH, that multiplication factor should remain constant, and the swap should at no point of time should change this constant factor. That's the important part. Again, like this is a very oversimplified way of like thinking about how AMMs work, but this is how you can imagine. And like there are other complex, and again, like this is something which we are talking about Uniswap v2. When the moment you come to Uniswap v3, the equation is also again changing it in a particular way, and we will understand why that too in the next slide. But this is how like a basic AMM is structured, and this is what the formula which is driving the equation and maintaining and ensuring that this is balanced. This always remains balanced because you are talking about real money here. So nothing should like increase the like it shouldn't happen that this, for example, this you can consider this. So this ETH bar cannot increase just by itself. If this ETH bar is increasing by this portion, the USDC part should decrease by this portion, equivalent. So that's the whole concept. I hope like by now it's clear. Yeah, now let's jump to docs. One of the best documentation in the entire industry for sure. The Uniswap documentation. Why I'm talking about Uniswap v2 in this perspective? Uniswap v2 is a past version of Uniswap. It's still very widely used, but the latest one is Uniswap v3, and like even a newer one is coming soon, v4. But v2 is relatively simpler to start with and relatively simpler to understand. And I will also going to be talking about the difference between v2 and v3. But you can start when you're trying to implement this bounty. You can use any of the v2 or v3. Obviously, like v3 will be a little bit more efficient, capital efficient. Why we are going to talk about that? Why it's going to be capital efficient? But you can use Uniswap v2 also for your like to work on this bounty statement. Now there are two major parts of Uniswap, like the Uniswap v2 code and the Uniswap v2 periphery. Okay, so let's get started. Should I go with the demo first, or okay? Before we go with the main contracts, one other part which I wanted to share. Let's share that, so then we can directly jump to the code part, and then we can from there we can pick up. So this is the chart basically x into y equals to k. That gives you this chart. And in this chart, we are going to understand like trades can happen at any point in the curve. Like the trade can happen here, the trade can happen here, the trade can happen here, any point of time. But reserves cannot go to K since K doesn't touch the axis. That's understandable. We just discussed about that. But what happens? This is a chart of Uniswap v2. The only difference between this and a Uniswap V3 is, I mentioned that V3 is capital efficient. What Uniswap V3 introduced is, instead of having the liquidity provided at the entire range, it has a set range. So, for example, why it's very practical, you can understand is, let's say ETH is trading at $2,500. And then we understood that people are providing liquidity. So if ETH is trading at $2,500, do you think it's efficient to provide a liquidity at $500? It's not, right? Do you think it's because if when ETH price is $2,500, will there be any ETH swapped at $500 ticker range? No, right? It's not possible because ETH price is far beyond. And do you think when the ETH price is $2,500, will trades get executed at the range where it's at 7,000? No, right? Because ETH price is still $2,500. Trades at 7,000 will just like they sit there. So what Uniswap V3 has introduced is like it has a sort of a level, like you can call it a level, in which like it has a price range. So when you are talking, when the price is at $2,500, the protocol will be efficient at the maximum point from, let's say, $2,200 to $2,700. Apart from that, the at given point of time, like that ticker range won't vary, right? More than that, probably. If things are very volatile, it can. But still, like take let's it's we're talking about maths. Let's take the like probability and like the maximum ranges, because when ETH is suddenly, it can't be right that ETH is trading at $2,500 and suddenly ETH is trading at $2. That is just not a very realistic scenario. So that's the whole difference between Uniswap V2 and V3. And when you're working with Uniswap V3 contracts, there are a couple of more, when you're working with the functions, there are a couple of more, there are a lot of other things with which V3 has introduced, but this is an overview. There are a couple of more variables and a couple of more things which you need to pass. But Uniswap V2 is a much more simplified version. And if you're starting or working on an AMM for the first time, you should definitely start with V2. It will make your life much more simpler, and you will understand the concept much more in a simpler way. And yeah, let's get started with this contracts part, right? So we have the Uniswap V2 core and V2 periphery, right? Let's get started with, where are the contracts? Okay, this is V3. Wait. Yeah. So Uniswap V2 has like the core contract, the factory, and the pairs. Like we already discussed what the pairs are doing. The factory is just like is enabling the pairs, and we have the code, which is a singleton factory and many pair. Like it lives inside that sort of a way. But what we are going to talk about, do we have that function? Wait. Nope. I need to see the contracts. Where are the contracts? Okay, I can show you the contracts here. Like in the there are some I'm actually trying to find the contracts of V2. Let's first of all close this. Yeah, never mind. So let's jump to the VS Code editor first. So you will see like we need from, like we discussed about V2 core and V2 periphery. That gives us all the contracts we need to work on it. So what you will see is like in package.json, I have already installed Uniswap V2 core and V2 periphery. Now I am like only interested about majorly two contracts, the router and the factory contract. So you can see there's a factory and there's a router contract, and we are just implementing it from the directly because we have already installed the packages. The contracts are already locally installed, and we are just requiring the like creating the contract instances, and we are just deploying. So this is a simple script, and we have configured the Shardeum DAppNet. So Shardeum has 2 testnet live right now, but like it's much more recommended that you work on DAppNet. You can get the details of network endpoints from the Shardeum documentation. So this is the validator net, and this is the DAppNet, and DAppNet is where we will be deploying. I want to show the contract also. One sec. Let me try again. There are primarily 2 functions which you need to understand, and is it in pair? Nope. Never mind. So yeah, so we are in this script. This is a simple script. I can drop the link also at the end of the session. It's a simple script which I developed, in which like you can deploy the Uniswap, the major contracts. Yep. So this is the GitHub repo which I'm using. You can use this also, and I'm going to drop the link later. But basically, that you can just clone it, and like you can do an npm install, and you will get to this stage. And yeah, basically what we are doing is like we have already installed the 2 major part, as I mentioned, the core and the periphery, and this will give you all the contracts needed you need to work on. And basically the script is just simple, like if you have worked with any other contract, like creating a contract instance and just deploying it, and just console logging the addresses. So let's just let's deploy it on the Shardeum DAppNet. It's configured. I have a env file with a private key which I'm not going to show, and we have the Shardeum DAppNet configured. So hopefully we will soon start to see the contracts getting deployed. And this is basically you can use as an entry point to when you whatever you're building. But specifically for the Shardeum Bounty challenge, you will need to deploy the router, the factory. All of these contracts are required, and then moving forward, then you can start building on the challenges. So now you can see like the factory contract is deployed. It has given me the address. I can go to explorer dapps.shardeum.org, and yep, you can see the contract is deployed. And it will deploy a couple of other contracts like USDT and USDC, and it will also deploy wrapped SHM. Wrapped SHM is just wrapping over, like making sure like you can use like wrapped ETH or wrapped SHM. Like in any of the protocols, you will always need wrapped version of the native ETH. Okay, some transaction on error. So that can sometimes happen with the Shardeum DAppNet, but yeah, we are working on it, and hopefully it will run this time. Yeah, so what I was talking about wrapped SHM, so that is one of the key requirement when you're calling some of the functions and when you're dealing with liquidity pairs and all. So you need to deploy wrapped SHM also. It's nothing, just it shows equivalent amount like of SHM just as an ERC20 token format, so it's easier to swap and stuff. So when you are swapping between SHM to an ERC20, the SHM gets converted to wrapped SHM and then it's swapped. So that's a basic like overview of why we need a wrapped SHM token. In case of like other blockchain, you have similar wrapped tokens. Yeah, so that's basically it. Like with this contracts, hopefully this time it doesn't give a nonce error. Then we can move forward. But yeah, let's while it's deploying, let's see. I should have bookmarked the link. My bad. I want to show 2 functions which are primarily required, and yeah, the router contract. Yeah, finally. Cool. So this is the contract which I've been trying to find so far. The what basically you need is, like, you can see wrap teeth. Like, this is basically same. The wrap teeth. This is in context of Ethereum, but we have wrapped SHM in Shardeum, and you have general functions. The add liquidity before making a swap. You need to add liquidity. You need to have the remove liquidity. Then you will also see remove liquidity function. These are functions which you already have access to because you have already deployed those contracts. So my wrapped SHM is also deployed. So if anyone wants to do an interesting thing is, you can send this, you can send any amount of SHM at this contract address, and you will see that you will get, I'm dropping it in the comments, no, private chat if you can share. So yeah, you can, if you are on the Shardeum DAppNet, you can drop any amount of the, like, you can send from your wallet any amount of SHM token, testnet SHM token, and you will see that soon, like, in your wallet, you will receive an equivalent amount of wrapped SHM token. So that's the ERC20 version of SHM, and that's like how a wrapped ETH or wrapped SHM token works. But yeah, so coming to the part now that I've found router, yeah. Now the two major functions which you need to work with, and it's also like uh, given at the bounty statement, is, let's see, yeah, swap exact tokens for tokens. Like, this is the function which you need to swap between two ERC20 tokens, for example USDC, USDT, and vice versa, and all those stuff. This is the function which you call to make that swap happen. And token for tokens, and this is the swap exact ETH for tokens. This is the function you call when you're trying to swap between the native token and any ERC20 token. For example, like SHM to any ERC20 token. So these are the two functions which I wanted to show, and these are the two functions which is in the bounty statement, and these are the two functionality which you need to implement in your automated market maker, which is parallelized as, um, so that the basic, like, I'm going to jump into the presentation also on what are the problem statement and the details, but these are the two functions which you need to work on. And if you see in the, like, the GitHub repo which I shared, there will be a test folder also, and there will be two files also to demonstrate, like, if you want to swap between token A and token B. So one is make swap. This is a simple swap, and when one is make swap with like AA, it is basically implementing, you will see the access list. What AA represent is automated access list, which is a Shardeum function. So big, as I mentioned, like, Shardeum does that for you. You don't need to mention the access list. If you don't give the access list, Shardeum will create it for you. But I just, like, in this case, we have given the access list for just for testing, and, like, you can pass a transaction with both the access list included or the access list not included. That doesn't matter. If it's not included, the protocol will create one for you, and then the transaction will be sent to the network. And that access list is, again, like, everything is tied down. That access list is the part where we talked about in this slide, right? In this slide, this is that access list. Now, in this case, this is just random numbers, but that access list is basically a address book which tells the protocol that what shards to form, which nodes to pull in. So that's how, like, how everything is tied into each other. But yeah, that's pretty much it, I think. And let's, with that, I think, let's get to the problem statement. Yeah. So I've given a demo also on how you can deploy the important contracts and start with your, uh, before that, once, let me show you. For example, if you have the make swap function, right? So why I told that that function is important, you can see, like, once I created a router, there is somewhere a router implementation. And once it's instantiated, like, you can call swap exact token for tokens. What this script will swap between two tokens. So yeah, so these are the two primary functions which we, thankfully, I found it. So yeah, now I feel better that I can share it. So yeah, like, now let's get started with the problem statement. The problem statement is basically what we all just heard and learned so far. An automated market maker maker that is optimized for parallel processing of individual token pair transactions. Why is this even possible? Because we learned in Shardeum, consensus is done on a transaction basis. So this gives you a much more leeway to work with. The AMM should process individual token pair transactions in parallel, be capital efficient, enable greater throughput. So the capital efficient part comes in if you use Uniswap v3. If not, it's still fine. But parallel transactions, if you're, as I mentioned, like if your contracts are living on other like shards, the transactions are since individually consensus, like you can have parallel transaction as long as the transaction you are making, you cannot make a swap between one token to another and then again create one swap between one token to another if the first one has not finished entirely execution. So in that case, it still needs to be linear. But for example, if someone is swapping between ETH to USDC and then someone is swapping between USDC to ETH, and in case of Ethereum, every transaction will be done line by line by line. But in case if those transactions are not related to each other, and if these transactions are not interdependent, those transactions will do parallel processing in Shardiums, and that's the beauty of it, and that's the challenge statement on how like you can make that happen and how you can work on it, because you have been given the tools, you have been given the atomic composability. Now the challenge statement is how you will use that to build a parallelized AMM. And yeah, adjusting dynamics trading fees based on network conditions, manage liquidity pools in a scalable manner. Again, like if each of your liquidity pools lives in a separate contract, it's much more efficient in case of even Shardium, because like again, like those pools can, irrespective of each other's operations, can interact with each other and make transactions happen as long as those are not interrelated transaction. If those are interrelated transaction, then transaction one needs to happen first. Only then it will move ahead. And the reward is $5,000. The detailed requirements are this: like current AMMs are not designed to optimize and parallelize on network. EVM in its nature is not parallelized, like it's not parallel execution. There are some non-EVM chains which can do that, but EVM in itself cannot. But Shardium is an EVM compatible chain and it still can. Why? Again, coming to the part where like it's the transactions are done on a consensus basis, and each of the shard in itself is acting as an EVM of its own. So that's why it's possible. And yeah, during this explained basically what I just explained. That in dynamic state sharding, it's possible for token pair transactions to be parallelized on Shardium. This approach enables atomic composability even in transactions where contracts are hosted on different nodes. We already discussed about this, and these are like some of the features which we have asked for. This is the main part. The rest of the part you can like, depending upon, as a step one, this is what we all need. Like this is the ultimatum. So you can then work on capital efficiency and greater throughput and scalability, liquidity pool management. And yeah, the expected deliverables on why I was running around and thinking about why I couldn't find that function is because of this. It's mentioned in our problem statement that you need to implement the ERC20 to ERC20 swap and the SHM to ERC20 swap. And I showed you which functions work on that functionality. You just need to work on how to make that parallelized. So you have been given all the tools, and that's basically the challenge statement. The documentation, the basic documentation on how you have implemented and how the transaction flow. You don't even need the documentation in this case. Like what we mean by documentation is you can just create a diagram which shows the transaction flow of how one transaction, a swap between an ERC20 to ERC20 is being routed in your contracts and whatever like application you build, and how that parallelization is happening. So if you are able to show that, like that's pretty much the expected deliverable. And yeah, smart contracts, any off-chain components. You can use initially an off-chain components to route your transactions. Also, you can use centralized system in between as an initial step. See, the final goal is to reach a parallelized AMM, but to reach that goal, that is a pretty high goal, and that can be a pretty complex goal to achieve. To reach that goal, like you can use some intermediate steps. So initially, you can create something which uses a routing mechanism. It can be in a centralized server, for example. Again, like we are working on testnet scale, so it's fine. But moving forward, we may need to figure out a solution of doing that in a decentralized way. But for just for this problem statement itself, if we just say like it needs to be in the entirely decentralized way, that will become too hard. But just from the problem statements, you can use intermediately centralized system to route your transactions so that the parallelization is happening. And you can like even in case of Shardeum, you can deploy multiple contract instances, same contract multiple times, and you can probably route those, because if the transactions in those contracts are different, then they will happen parallelly. So that's how that you can achieve the goal, which the bounty statement which we have given. And that's pretty much the expected deliverable and the overall thing. And the evaluation criteria, again, like I think in they have already shared the Notion page. You will get all of these details also, but I just wanted to quickly go through and showcase what's expected in this submission. And yeah, that's pretty much it. Thanks. If you have any questions, we can then start on that. I think you're muted, Preeti.
Sorry. Thank you for the session. I'm pretty sure people who are watching it right now will watch it later for the BRB bounty. It will be very, very helpful. There are a few questions, but I think you've already answered them on the way. There's one question. Can you share the code links? Do you have the code
Okay, yeah.
link?
Yep, I've shared the code link in the chat.
This goes here. This is a private chat.
Yeah, I think you will need to share that. I
Yeah,
don't think I've
I
joined
did
that
it.
chat.
Like,
Yeah, thanks.
yeah. Um, awesome. So I don't think so. There are any other question, but if you do, it's the time. Or you can also put it on our Discord. We're always hanging out on our Discord or Shardim's Discords. But yeah, that was it. And thank you for the session, Sandipan. It was really nice having you. And I'm pretty sure people will find this super helpful, especially for people who are doing it later. Somebody's asking again if the code is private.
No, it isn't. Like it's a public repo. Let me know if you're unable. You should be able to access it. Yeah, it's a public
Yeah,
repo.
it's a public repo. I can see it. It's a public repo, so you should be able to access it. But I don't think there is any other question. So should we wait for like a minute and then just end this stream? Yeah,
Sure, sounds good.
does that work?
Also, like for the people who have like heard about many of the things for the first time, it can be a little bit overwhelming. This is like DeFi stuff. DeFi stuff is in general overwhelming, and but like don't get like afraid of this. Like you can Uniswap has excellent documentation. Just by reading through it, you can get a lot of insight. And start with V2 if you are not very proficient with working with DeFi. Start with V2,
Mm-hmm.
and then you can move forward in V3. So that's like the two things which I wanted to share.
Yeah, definitely. Thank you for answering that. But will we seeing you at ETH India?
Yeah, for sure,
Yeah, then let's meet there. It will be fun.
definitely.
Yeah, awesome. I don't think so. We have any other question, but I think that's it. I think we could just end the stream. Thank you, everybody, for whoever joined it right now or will be watching it later. Thank you so much for coming, and thank you, Sandipan, for taking out the time for us.
Thanks, everyone. Thanks a lot for having me.
Bye.